Okay, today we are going to learn about the chain rule, which is used to take derivatives of a composition of functions. So a composition of functions. So what I mean by that is, let's take a look at our first example, which is sine of x squared. Okay, so if I want to take the derivative of the sine of x squared, so d dx, what I have here is I have two functions. Okay, so I have a composition of functions, one inside the other. My first function is the sine, and my second function is x squared. So what I really have is I have one function inside the other. Okay. So if I want to take the derivative of this, the first thing I do is I would start with the outside function, sine of x. According to this, sine of x is the outside function. So I'm going to take the derivative of sine. So the derivative of sine is cosine of something. And the something that goes in there is everything to the right of sine. So x squared. Now I am done with the first part. So what I want to do is I want to take the derivative of the inside part. So the derivative of the inside is just 2x. So multiplying those together, I could rewrite it as 2x times the cosine of x squared, which is the derivative of sine of x squared. Okay, so let's try another example. Let's try one where it's just a little bit different, but I have the sine squared of x. Okay. So now I have two different functions here. Well, actually I have three, because I can write this as the sine of x. Remember, the whole thing is squared. So what I have here is I have a few different functions. I have the outside function, which is the squared, and then I have the sine of x as my inside function. So the way it works is I take the derivative of the outside and I work my way in times the derivative of the inside. Alright, so taking a look at the outside function, I have the squared function, which is my outside function. Okay, so that is this right here. So the derivative of that, just like it's written, is using the power rule. So the power rule is going to be 2 times that to the first power. And what goes on the inside is everything to the right, sine of x. Now I'm done with this, so I'm going to take the derivative of now sine of x. So I'll take the derivative of the inside function right there. The derivative of the inside function is cosine. Is cosine of x. So if I were to take the derivative of the sine squared of x, my final result would be 2 sine x cosine x. Okay? And I can rewrite it without the parentheses and to the first power, but that's just what I'm doing. I'm taking the derivative of the outside times the derivative of the inside. Now here I only had two functions. I had this function right here, and I had this function right here. It does get a little more complicated when I have more than two functions. So let's take a look at that example. Okay, so let's take a look at something like we'll do tangent. So I'll do tangent of the square root of 5x to the fourth minus 2. And what I'm going to do is I'm going to take the derivative of this. So now I have more than one function listed. So if I think of my outside and work my way inside, here's all my functions. I have the tangent. So I have the tangent of something. I have the square root. And then I have my inside, which is 5x to the fourth minus 2. So that's what I have as far as all this function goes. Now, remember, this inside function, right here, the square root, so this function right here, the square root, I am going to write that as to the 1/2 power. Okay, so instead of the square root, I just rewrote this to the 1/2 power. So now I am taking the derivative from outside to inside. Okay, so very first thing I'll take the derivative of is tangent. Okay, so here's what I get. Taking the derivative of tangent, I get secant squared. Secant squared of everything else. Now what goes down here is everything else to the right hand side. So that will be, oh pickles, the square root of 5x to the fourth minus 2. Now what I do is I am done with this first function, and now I got to take the derivative of the square root. So I take the secant squared of the square root of 5x to the fourth minus 2. The derivative of the next part is 1/2 something to the negative 1/2. And what goes inside is everything else to the right, which is 5x to the fourth minus 2. Now I'm done taking the derivative of that middle part. So the very, very last thing I got to do is I got to take a derivative of this last part. And the derivative of that last part is just 20x to the third. And that right there completes the innermost function. So the derivative is this whole thing of secant squared square root of 5x to the fourth minus 2 times 1/2 5x to the fourth minus 2 to the negative 1/2 times 20x cubed. Whoa, that seems like a lot. So we're going to do one more because I'm reaching close to 9 minutes here and I don't want to go too much over. But let's just take a look at something like sine to the 3x all over x squared. Okay, so let's take a look at this function. F of x. Oh, nope, don't want to do that. F of x equals sine to the 3x, or sine of 3x, all over x squared. Now what I have here is I have a division of these functions, so I'm going to have to use the quotient rule. And when I take the derivative of sine of 3x, I'm going to have to also include the chain rule. So if I go through and take the derivative, so f prime of x equals, I know I'm going to have a quotient, low d high minus high d low over low low. So here we go. I can do low d high, so low is x squared. The derivative of sine of 3x, remember, can be written as the sine, and then 3x. So when I think about low d high is going to be the chain rule for this. The derivative of sine is going to be cosine, and then what goes in the inside is everything to the right of 3x. I'm done with sine, and now I'm going to take the derivative of 3x, which is just 3. Okay. So that right there is low d high using the chain rule for the derivative of the high. So now I'll get rid of all this stuff. And when I do minus high sine of 3x, the derivative of d low is 2x. Three x squared cosine 3x minus 2x sine 3x all over x to the 4th. Come on, there we go. All right, now that is it. If there's any questions, we'll go over more examples in class, but hopefully this gives you a good idea of where to start and what to do. Later.